freecoachingtoday.com.
So this is the third problem in H.C. Verma's physics, chapter 11 of gravitation. We have three masses m placed at the three corners of an equilateral triangle. Find the force exerted by this system on a mass m placed at the midpoint of a side. So we'll do the first part, and the second part is find that force at the center of the triangle. So this is the triangle. You make an axis. This is x-axis. This is y-axis. The masses are m, and we need to find out the force exerted by this system at this point. So we are going to, let's say, call it mass point 1, 2 and 3. The force that acts on this particle due to this one along the x-axis, and the force acting on this particle due to this particle acts along the negative x-axis. So these two forces cancel each other. The net force is 0. So basically, this is the direction of the force on this particle. This is the direction of the force on this particle due to this one, and this is the direction of the force on this particle due to this particle. So these two forces essentially cancel each other. That results in the force due to this point number 3, and this is going to be F is equal to G m1 m2, which is m square divided by r square. R is this distance, and we know that this distance is going to be, this is 60 degree, so this side is going to be a sine 60 degree or a root 3 divided by 2. So our distance is going to be a square root of 3 divided by 2 whole square, or 4g m square divided by 3a square. The next problem is finding the net force at the center of the triangle. In this case, we will not completely solve this, but intuitively point it out. Now this is a completely symmetrical system, and these three forces, they act in such a way that this is a force going to be in this direction. Let's say the force acting on this particle due to this particle is going to be in this direction, this force is going to be in this direction, and this force is going to be in this direction. And since these masses are same, if the masses were different, the forces will have different magnitude, but these masses are same, and the distances, whatever it be, x, it's going to be the same. The forces F1, F2 and F3, they are going to be exactly the same. And you can think of that this is in this kind of system, the net force is going to be 0 because of the symmetry. If you want to, you can always try to solve it by finding the magnitude of this force, solve it along the y-axis direction, same thing for this force, and the same thing for this force, and then find out the resultant along the x-axis direction and the resultant along the y-axis direction. You will find that the net force is equal to 0.